Alright, the object of today is to find areas of rhombuses and kites, find angle measures in areas of regular polygons, and to find areas of composite figures. Alright, so the formula to find the area of a rhombus and a kite is 1/2 diagonal 1 times diagonal 2. And that's what you do to find each one of these. So that means this whole diagonal times the whole diagonal of the second one. So let's try an example. Find the area of each rhombus or kite. Alright, so we have 8 meters is this first diagonal. It doesn't matter which one's D1 or D2. The second one is 6 meters. So we're going to use our formula. A equals 1/2 D1 D2, and then you plug and chug. So area is equal to 1/2 8 times 6. 6 times 8 is really great because it equals 48. So 1/2 times 48, or 48 divided by 2, is 24 meters squared. Don't forget your units is squared because it's area. Alright, so the second one, same thing. Area is equal to 1/2 diagonal 1 times diagonal 2, so 7 times 10. Area is equal to 1/2 times 70, so area is equal to 35 centimeters squared. Alright, moving on to our next concept. Over on the left you see a circle and it has a polygon inscribed, means it's inside. We have a new word, it's called an apothegm. So when you have some figure, you go from the center of the figure and you go perpendicular to the side. That is called the apothegm. Okay, it's really important. This is what we're going to use in our next formula. Okay, you also have what's called a central angle. So if you go from one vertex to the center to the next vertex, that angle that was made, that's a central angle. Okay, and we also have our center. So you can actually look at this picture and you can see how it relates to a circle. Also, these lines I just drew to draw the central angle, those are also the radii, or radius, of the circle that's on the outside. Alright, for our second example, we're going to find the angle measures in a regular polygon. Alright, so we see ABCDE is a regular pentagon, and we're going to find each angle measure. So the first angle we want to find is AFB. And since we see that it goes from one corner point to another corner point, this is actually a central angle in our polygon. So if you think about a circle, it goes around 360 degrees. So we're going to take 360, and we're going to divide it by how many central angles we have. Well, you can count 1, 2, 3, 4, 5. We're going to have 5 central angles. So 360 divided by 5 is going to give us 72 degrees. So that is actually what AFB is equal to. Alright, for angle B, or for letter B, we want to find the measure of AFG. Well, we know that this is an isosceles triangle, and we're actually cutting it at half. So if we know that this central angle is 72, we just need half that angle now. So half of 72 is 36 degrees. And for the last angle, we want GAF, which is this blue angle I just drew. Okay, I'm going to redraw that triangle so you can kind of see it. We actually have a right triangle, so that's 90 degrees. We just found our top angle, which is 36, and we know that all triangles add up to 180, so we can do 90 plus 36, which is 126, and then subtract from 180. And we get 54 degrees. Alright, so to find the area of any polygon, that means any side, you're going to take your area is equal to 1/2 your apothem, which is little a, times big P, which is perimeter. So let's go ahead and label what those are. A is apothem, that's the length, and then we have the perimeter of our figure. So let's try an example. Alright, so a regular nonagon is inscribed in a circle with a radius of 4 units. We're going to find the area of the nonagon. Okay, well, first we need to find the central angle. Okay, and to do that we have to take 360 divided by 9 because we have 9 central angles, and that's going to give me 40 degrees. Okay. Second thing is I'm going to redraw that triangle that we see right here. I know these lengths are going to be 4, and this is how we're going to find our apothem. I know that my central angle is 40, so if I cut that in half to get a triangle, I know that the top angle now is going to be 20. Okay, so now we're going to use trigonometric ratios to find out what our side length is and what our height is. Okay, so if we look at 20, we have our opposite, we have our adjacent, which is our height, and then we have our hypotenuse, which is 4. So if we use opposite and hypotenuse, which O over H, that goes with sine, so the sine of 20 degrees is equal to x over 4. Okay, multiply both sides by 4. So in your calculator you need to plug in 4 sine of 20 degrees. Now, if you go ahead and plug this into your calculator beforehand, make sure that you don't round it until the very, very end. Or you can just leave your answer like that for now and then plug it all in at the very end. Alright, the next thing we're going to do is find our apothem. Okay, our apothem is actually this height of the triangle, which is our adjacent leg to our hypotenuse. Okay, so adjacent and hypotenuse go with cosine. So the cosine of 20 degrees is equal to y over 4, because that's my hypotenuse. Multiply both sides by 4, and we end up getting our height, or our apothem, to equal 4 cosine 20. Alright, so I'm going to go ahead and erase this. Alright, so let's recap on what we have so far. We do have this piece of our leg. Okay, we know that that's 4 sine 20. So to get the whole side, I'm going to have to multiply this by 2 to get our whole side length. So that's actually 8 sine 20. So to find our perimeter, we know that we need 9 sides. So we're going to take this and multiply by 9. So 8 times 9 is 72. So this is 72 sine 20. So this is actually our perimeter, our big P. We also know that our apothem, little a, is 4 cosine 20. So we actually have everything to plug into our formula now. We know that the area of a regular polygon is 1/2 little a big P. So we'll just plug in what you know. 1/2 little a, which is 4 cosine 20, big P, which is 72 sine 20. And now you can go ahead and plug this into your calculator and you'll get your full answer, which should be 46.3 square units. Alright, so next example. We're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides. And we know the radius is about 19.6 inches. What are you covering? Alright, so the first thing we want to do is find the perimeter. And you always want to write down your area formula 1/2 AP. So that way you know what you're looking for. We need our apothem length and we need our perimeter. In this case, the perimeter is a lot easier to find because we know that one side is 15. And we also know that we have 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to take 15 times 8, and that's going to give me my perimeter, which is 120 inches. So we know that this is 120. Alright, so now we just need to find our apothem. So what we're going to do is we're going to draw from the center of our octagon, perpendicular to the side, and then we drew a right triangle. Okay, so we actually know what the side length is 15. So if I want halfway across it, it's going to be 7.5 because I just divided by 2. I'm going to redraw this triangle so you can see it a little better. We know that our hypotenuse is 19.6. This side is 7.5. So I should be able to find my apothem by using Pythagorean theorem, which is a squared plus b squared equals c squared. A squared plus 7.5 squared is equal to 19.6 squared. And when you solve that, your apothem is about 18.108. Alright, so we have everything we need to plug into our area formula. Okay, A equals 1/2 18.108 times 120, and we get the area to be approximately 1086.5 inches squared. Alright, last example, we're going to find the area of composite figures. Okay, so what you want to do in a composite figure, you want to try to break up your shape into shapes that you already know how to find the area of. So if you look at A, we have a regular hexagon, and we also have a trapezoid. Okay, so the area of the composite figure is going to be the area of the regular hexagon plus the area of the trapezoid. And you want to think about your area formulas. Okay, so the regular hexagon has 1/2 little AP, and then the area of a trapezoid is 1/2 base 1 plus base 2 times height. Okay, so we need to find each of these pieces. Now, if we think back to the apothem, okay, we have that little representative triangle. We have the bottom is 0.8. We have the radius is 1.6. So we can do Pythagorean theorem to find our apothem. Here's how you set it up. A squared plus b squared is equal to c squared. A squared plus 0.8 squared is equal to 1.6 squared. And we get our apothem to be 1.386 inches. Okay, so we have our apothem. Now we need our perimeter. So we know that this side length is 0.8. So if I multiply that by 2, I'm going to get the whole side length, which is actually 1.6. So I have 6 sides, and I'm going to take 1.6 times 6, and that's going to give me my perimeter, which is 9.6. So I have everything to plug into my first formula, 1/2, my apothem, which is 1.386, times 9.6, which is my perimeter. Now I need 1/2, and then if we look back at our trapezoid, base 1 is 1, base 2 is 2, and we have our height, which is 1.5. So 1 plus 2 times 1.5. And you can actually plug this whole thing into your calculator, and you should get your area to be about 8.9 inches squared. Alright, for time's sake, I'm not going to do B and C, but if you're curious on how to do it, please ask your teacher. We would be happy to help you solve these. Maybe we'll even get some extra credit. Who knows? Alright, have a wonderful day.